Hello everyone, in this video we are going to see about the first topic in computer graphics, which is the video display devices. So as the name implies, these are the devices which helps to show the videos on the screen or the image on the screen. That is the video display devices, and the primary output devices in a graphic system is the video monitor. The operations of most of the monitors, video monitors, is based upon the standard cathode ray tube. So we have a common standard device called CRT, which is the cathode ray tube, and this is the base of almost all the video monitors. Let us see how this cathode ray tube works. So there are many types of video display devices. They are the cathode ray tube, raster scan display, random scan display, color CRT monitors, direct view storage tubes, and the flat panel displays. These are all the different types of video display devices, and let us see about the first one, which is the cathode ray tube. So the definition of this cathode ray tube is CRT stands for cathode ray tube. It's a technology which is used in traditional computer monitor and television. Cathode ray tube is a particular type of vacuum tube that displays images when an electron beam collides on the radiant surface. So this is the basic functioning of how the cathode ray tube generates the image on the screen. Okay, so now the basic thing is that electron beam generates electrons, and that collides on the radiant surface. That is, the radiant is the one which gives the light, which is like example like a phosphorus is a radiant element. So when the electron collides on the radiant element, it glows, the light is on. So okay, that is the basic functioning of this cathode ray tube. So let us see in short how the cathode ray tube works. Heat is supplied to the cathode ray by the filament. The free electrons are then accelerated towards the phosphorus coating by a high positive voltage. A positively charged metal coating on the inside of the CRT envelope near the password screen. Intensity of the electron beam is controlled by setting voltage level on the control grid. A smaller negative voltage on the control grid simply decreases the number of electrons passing through. So what does it mean is, we have the filament. That filament, when it is switched on, it generates heat, and in that, while this it is heated up, free electrons started to pass. So they accelerate, means they go in a various speed, and it flows towards the phosphorus coating, which is the high positive voltage screen, high positive voltage, and a positively charged metal coating on the inside of the CRT envelope near the phosphorus screen. So the CRT screen, there is a monitor screen that has the phosphorus coated screen. Okay, so now when this positively charged metal coating is there, it attracts the negative electrons. Okay, so now when the positive and the negative this electrodes combine, it creates some energy or the light. Okay, so intensity of the beam is controlled by setting the voltage. So when you have high voltage, we can have the high intensity beam. When the voltage is low, then we'll have the number of electrons will be less, and therefore the energy also will be less. This is the basic functioning of how the CRT works. Let us see the diagram of the CRT. So this is the diagram of the CRT, cathode ray tube. So you can see here there is a connector pin there you plug in, and there is a base is there, and then we have the electron gun is there. So electron gun, when it is generated, when it is heated up, it generates the electrons, and that electrons pass through this tube. Okay, so when the electrons are produced, they are scattered all over the tube. So this focusing system helps to focus those electrons in some direction. Okay, and when they are focused, they are come into closer to each other. So the acceleration also will be more, and what happens, and then those accelerated these electrons will be controlled by the horizontal and the vertical deflection plates. So these plates have the two different directions, up and down, vertical and horizontal. That means the electrodes are accelerated up and down. That means the speed will be more and more. When the speed is more, naturally the energy will be more, and it will create a positive high energy. Okay, so now you can see the blue line, that is the line of the electron beam, and it passes and it just focuses on the phosphor coated screen. When it is focused on the phosphor coated screen, it glows, it is on. That means it gives the light energy. So this is how the electron beam works. Okay, so internally we have the diagram, internal diagram is given over here, which says about the heating filament is there. You can see the red line. Red component is the filament which is heated up. What happens? It creates the energy. So it is covered by the cathode, and once it is heated up, the heating filament heats the cathode, and the cathode generates the electrons, and the electrons goes in, that is, it is shown in the blue line, and the control grids are there which focuses, and then there is a focusing element, just we have seen in the previous diagram, and then we have the focusing anode and accelerating anode. So what does it mean is, cathode are having the negative energy and it is attracted by the positive energy, which is the anode. So just remember, anode is positive, A plus. Okay, so now these cathodes are generated from the heating filament are passed through the attracted by the anode, and it is accelerated, and we have also seen the diffraction plates which moves the electrons up and down, and it will be attracted by the phosphor coated screen. Okay, so this is how the cathode ray tube works. Based on this functioning, a cathode ray tube works. So the components are given, just you have seen in the diagram itself. Electron gun, this is made up of several elements, mainly the heating filament and heater. Okay, that's a cathode and a cathode. And then the electron gun is a source of electrons, because when it is heated up, it creates the electrons, and that is focused by a narrow beam. Next we have the anodes, focusing and accelerating anodes. So as we know that these anodes are used to attract the cathodes. So these produce a sharp narrow beam on the of electrons. And once it is focused, the beams are narrowed up, and we have the horizontal and vertical deflection plates. These plates helps to guide the path of the electron beam. So electron generated from the electron gun, it passes inside the tube, and the accelerating anodes regulate it, make it into a narrow line, and this horizontal and vertical deflection plates moves the electron vertical and the horizontal direction in order to create more energy. So these plates, what does it do is, these plates produce an electromagnetic field that bends the electron beam through the area as it travels. So these deflection plates create the electromagnetic field. So that will help to move the electron, bend the electron beam, and it passes through the area. And we have the phosphor coated screen. The phosphor coated screen is usually, it is used to produce the bright spots when the high velocity electron beam hits on it. Okay, so this is how the screen gets the image of the picture, or the whatever video or a picture, whatever it may be, whatever you wanted to display on the screen. This is how the screen is made to glow, and this is how the video display device works based upon the CRT. Okay, hope it is simple to follow, and thanks for watching.